Yesterday we talked a lot about jacks and strands. Could you talk a little bit more about these harnesses that you're having to check now since we're in the stopping stage?
In order to grab a hold of the truss,
Sorry, could you come up to your mic?
sorry. In order to grab a hold of the truss, we created big steel harnesses that actually wrapped around each bearing plate of the truss. And those harnesses are connected to each other and connected to the jacks via the strand system. So that's actually what's pulling the bridge right now.
So was there an issue with it that you had to stop temporarily?
Just an adjustment.
Okay.
Yeah.
Okay, so I wasn't here yesterday, Charlie. So tell me, when you're talking about jacks and harnesses, but physically, how is this bridge being pushed? And is it piece by piece, or is it the whole thing all at once?
Yeah. It's being pulled. If you look out at the bridge, you can see off the end of the piers, the upstream end, at the land spans, there's a single jack, and the three river piers have two jacks on them. For those that remember, when we lifted the two main spans to the bridge, we used large hydraulic jacks and these steel strands to physically lift it. We're using the same jacks and the same strands to pull it sideways now. It's just a process of using hydraulics and a regular hydraulic jack that has a cylinder that comes out of it. So as that cylinder extends, it pulls those strands with it. And when it meets its maximum stroke, it locks off the strand, relaxes, grabs a hold of the strands again, and pulls again. So each time the jack moves, it pulls the bridge about 20 inches. And everything working as it should, it takes about a minute and a half for the jack to pull and recycle. So
Can you point that out on the
fast.
photo?
Yeah, this, as we say.
Yeah, okay, sorry. Yeah, so here's your jack. What you don't see are the strands that are in here. So you can imagine these steel strands coming through the jack out over the rollover stand. And each time this cylinder moves out 20 inches, it pulls that strand with it. It grabs a hold of the strands using a wedge system. So each strand, which is 5/8 of an inch, has 7 wires in it, fits through a strand plate that keeps them in a line. And part of that is a wedge plate that each time it has to grab the strands, those wedges lock down around each strand. And so it would grab the strand, pull it, and then when it's reached its maximum stroke, it'll grab a hold of the strands back here and hold it. This will relax. This will grab a hold of the strands. This end will relax, and it can pull it again. It's called strand jacking. So that's how it pulls it.
How about for the sliding plates too? Those right now.
This picture shows the plate that we're actually sliding the bridge on. Now this is just a steel plate that's been polished to a mirror finish. On the bottom of the bearings is a Teflon pad. So what you ultimately have here is a Teflon pad being pulled over a mirror finish, which is coated with a high strength or a high temperature grease that's designed for this kind of application. So you're sliding Teflon against grease on top of this mirror finished plate. And that's what keeps the friction way down to allow it to slide. When you hear the term sliding in the industry, whether you're moving a bridge or some other kind of structure, it's always this application here. Something really smooth on greased surfaces, highly polished. So. Does that help?
How many inches would you say it's moving in, I don't know, in an hour? If inches, I don't know.
When we made the first pull out, it was indicating it could probably pull it full stroke in an hour, probably 15 to 20 feet, because everything's going okay. So we could, if it worked correctly, pulling out this first 25 feet, within the next hour and a half or so, you can see the bridge about halfway across. So that's the best case scenario.
I see on what appears to be Pier 5, occasionally there is welding or cutting torch work. Can you explain what they're doing
That
there?
was part of the adjustment we just made.